Have you been hacked by assembler? Hello computer cowboys. Today I would like to show how easy it is to hack a program using assembler even if it has already been compiled and you do not have access to the source code any longer. For this I have created a typical Hello World program in C. Find it here. It does nothing but print out Hello World. Let's compile it. And execute it. It does exactly this. It outputs hello world. But now let's see how it really looks. Let's look behind the scenes. How has GCC translated this C code into machine language? Using the command cat does not really help. It only outputs rubbish because that is binary. This is mainly consisting of characters that cannot be represented as a letter on the screen. So let's use a hex editor instead. Let's use okteta. And then inside okteta, we see on the left side the bytes. For example, here the byte 7F hexadecimal. It cannot be represented as a letter, so it is represented as a dot over here. And here on the right side, we see the clear text, how that code would be written in letters. Okay, let's now search for the UTF-8 string. Please look that up in Wikipedia why we are using UTF-8. It's super interesting, but not part of this video here. So let's look for hello world. And we find it down here. It starts with 68, which is obviously the letter H, and continues. Now, instead of hello world, we correct this now and we write hi moon. After hi moon, we make a 00 in order to indicate that this is the end of the string. And now let's save it. Quit and save. And we call it again. And it no longer says hello world, but it says hi moon. Ha! You have been hacked by assembler. A good way to work around this is to work with MD5 sums. MD5 sums calculate a sum out of the bytes in your binary. It's a bit more complicated than just making the sum of the bytes, but it helps a lot. So let's say MD5 sum hello, and we see this is a relatively long hexadecimal sum of the bytes in the program hello. And it differs from the original one. Let's try it. We again compile the original hello program, which outputs hello world, not hi moon, and again run an MD5 sum on this, and the MD5 sum is different. So always take care of the MD5 sum, compare it, and only if that is equal, you know that you are dealing with the original program. So this is against getting hacked by assembler. But there's more to it. Complete program flows can be manipulated using machine language and assembler. Let's have a look at the program flow of the hello binary. We use the command objdump -d for disassemble, -m like machine architecture, Intel. Then we hand over the program hello and pipe it into less so we can navigate inside this output. First thing you need to know is that you have to search for the main function. Here we have it. Here we have the memory address. Here the name of the function. Here the memory address shortened. And then here we have the command in machine language. So it's literally 4 bytes saying entbre, that is the mnemonic in assembler language. And you see that the machine commands have different sizes. This is a command with 4 bytes. This is a command with 1 byte. Typical for the Intel architecture, it would look differently if we were on a Raspberry Pi here. And now, what happens? It does something with security, backs up the register BP, moves some values around, and finally calls the function printf from the libc library. Okay, and this is how it's called in assembler. So printf, call printf is translated to E8, EB, FE, FF, FF. Okay, then let's look if we find this in okteta. We look for the hexadecimal bytes E8, EB, FE, FF, FF. And here they are. Here it calls printf. But if we override it with 90s, 90 hexadecimal, which stands for no operation, the processor will just do nothing when it comes here, so there will be no printf. Let's find it out if it's true. And you see, hello just runs normally, starts okay, ends okay, but it does not output hello world. Now let's look at a real world example. I have this beautiful video player that I love. It's called VLC, but it does not allow me to be run as root. I do not like this. So let's see that we get rid of this. Let's call VLC, or let's call it strace, to list all system calls that are in a program. And again, it says VLC is not supposed to be run as root. However, we see before it calls the function getEUID, get effective user ID. And this is something I want to operate out of this thing. So what do? I copy VLC to the to the directory I am in. And I do an object dump of VLC again. Search for getEUID. Here it is defined. Here it is called. So we see what happens here. Here it calls getEUID. Then it tests if the register EAX is 0, and then it jumps on equal somewhere. This somewhere will then just say, okay, you do not get in here. I want to override this jump equal call, so I have to override the bytes 0f8423010000. Best override them with 90s, so just nothing happens. Okay. So I do a okteta VLC. And again, I search for 0f8423010000. They are here. These are 1, 2, 3, 4, 5, 6 bytes. Okay, starting here. 1, 2, 3, 4, 5, 6 times. Now I quit again saving. Copy the file back. And now when I call it, it no longer says, hey, this is only supposed to be run as root. We have successfully operated out this functionality from a working real-world binary. And that is a bummer, I think. I mean, where this is really powerful, it means that you can change programs after they have been compiled. So I hope you liked my explanation a bit how inherently unsecure a computer really is. If you now go back to your life and say, I don't trust these computers any longer, I have reached exactly what I wanted to reach. Computer is an excellent hobby and a marvelous instrument that you can use, but it is not something that you should trust. And this video is a big plea on the fact that you do not use voting machines because they can be manipulated. It is a core competency of a computer to manipulate data and to be manipulated. People have told me, okay, this is all great, but with encrypted data, it cannot happen. Well, this is partly true in the sense that there must always be a program doing the encryption. And now if you put this program into the position to be the only one who can really tell you what's going on your computer, it's even more dramatic. So I would say do not trust computers. If you liked my video, please watch the other videos. Go to my homepage, stärk.de/Thorsten, and please leave a comment in the comment section. I answer them all, and I love reading them, and I hope to see you again real soon. Have a good one.